We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today in this lecture we are going to study about the series connection of resistances inside the circuit, and we will determine an equation for the equivalent resistance, because a range of combinations of resistance is utilized in the circuit. What will be, you can say, the total resistance flowing throughout the circuit and how it will affect the input and output voltages. So let's go through this article. Here in this figure you can see the series combination of resistance. N number of resistances have been utilized. The different colors have been used in this figure to assure you that each resistance have different values of their particular resistances, and as well as the symbols have been utilized non-identical. So here R1, R2, R3 and so on, Rn. So n number of resistance have utilized in this particular circuit. V voltage has been sourced to this electric circuit, from which the electric current capital I is flowing, and this K is the symbolic representation of key when it is turned on. Right now in this position we can say the key is switched on because the electric current is flowing. Suppose the electric current was not flowing, that means the directions have been disabled, then you can say the key is in the switch off conditions. So here why we are saying that this is the series combination, because R1, R2, R3 up to so and so Rn are in the linear combinations or in the linear connection with each other. So here you can say the series combination of resistors. Resistors are said to be connected in series between any 2 points if the same current is flowing through each resistor, or you can say in other words there is only one path available for the flow of electric current. So you can say among all these resistance, suppose here the capital I is of 5 ampere. Okay, so in the R1 resistor 5 ampere current will flow, in R2 resistor again 5 ampere current will flow, up to so and so. When you reach till the n number of resistors, that is the Rn, so here again the 5 ampere current will be flowed. So figure shows the series connection of n number of resistors R1, R2, R3 up to so and so Rn between 2 points A and B. So here the points have not been determined, but you can here symbolically represented as capital A, and here you can write down capital B. So by utilizing this particular phenomenon, the equivalent resistance, you can say either it as equivalent or the total amount of resistance which has been adopted to this electronic circuit. So when there is a series connection of these resistances, you can identify the equivalent resistance symbolically represented as Rs, because S subscript has been used to denote the series connection of resistance. So here you just have to do a linear summation, or you can say a simple addition of the value of each and every resistances. So Rs is equal to R1 plus R2 plus R3 plus so and so plus up to Rn is equal to, which has been generally written as, symbolically written as summation I is equal to 1 to n up to Ri. So this is the equivalent series resistance value. Thus, the equivalent resistance of the series combination of the resistors is always greater than the greatest value of the resistors connected in series. It is quite obvious, because suppose you have considered either of n resistances. We have taken three resistance, one of 7 ohm, another is of 14 ohm, and the third resistance is of 21 ohm. So what will be the total? So the total will be 42 ohms, okay, and it is much greater than that of the highest amount of individual resistance, which was 21 ohm. So this was all about the circuit, where the important factor is input and output current will be the same. So the effect will be obvious inside this resistance, which will directly affect your output voltage, but no affection on the flow of electric charges. So this is the important factor which you have to consider. The effect of resistance you will observe only on the potential difference and not on your electric current. Now, suppose we have a condition in which all these resistance values are identical. Identical means all the resistance are of equal values. Then if n identical resistors, each of value capital, are connected in series, then in that case the value of Rs will be R plus R plus R plus so and so n times. So we will ending up with the equation Rs, which is the equivalent resistance in case of series resistances, will be equal to small n into R. And here now, according to Ohm's law, we have the equation of voltage, that is capital V, as nr into I. So this is the modified Ohm's equation for series combination of resistors. So this was all about how you can connect the different resistances in the series condition, and how you will be able to detect the equivalent resistance value with which you can calculate the total resistance of the electronic circuit, as well as how will you able to find out or determine the voltage flow, like input and output voltage. And the major important factor which we have observed in this particular article is that no affection of this series combination of resistances towards the electric current. So again, this is the 4 marks question and important in view of your GTU examination. So be prepared for the same. You have to draw clean and neat diagram of this electronic circuit, as well as you have to mention all these parameters, these equations, as well as the Ohm's law equation. You have to mention each and every variables or the symbols utilized in your electronic circuit. So all these parameters you have to keep in mind to get full marks 4 out of 4 in the external exam. So thank you for visiting this lecture, and if you have any doubt regarding this lecture, you can post in the comment.